So there are two things that affect ocean circulation. And this is something that ultimately is, again, powered by the sun. And ultimately, it's actually really important because it redistributes the water on our ocean, specifically redistributing heat. So cold water is moved, picks up energy, and then can be transferred to the different land masses. So when we look at ocean circulation, one thing that affects it is surface winds. So one of the things that's really interesting about these surface winds is that they cause circulation of the movement of the water as part of that energy is transferred to the water as the wind rushes over the surface of the ocean. So at the equator, we have what are called, the winds are called easterlies. And that is because the winds tend to move towards the west from the east. And so when we look at the difference as we move up latitude, when we get between 30 degrees and 60 degrees, either north or south, then we have westerlies. And these push water in the same direction. So from east to west, water moves near the equator, and then it moves from west to east between 30 degrees and 60 degrees. So a diagram of this looks something like this. So what we see here is the latitude. So this would be the equator, and this is at 30 degrees. And you can see that the currents, if I look at this a little bit bigger, you can see the equatorial currents are, ooh, that's blurry, but they're going towards the east. So they're going to the west. So they're going from east to west. And then if we look at a little bit higher, they tend to be going the other direction, right? So here they're going the other direction from generally in that direction. But you'll also notice that they're creating little circular patterns. And this also has to do with the spinning of the earth. So the earth spins. And so you'll notice that in the Pacific Ocean, things tend to spin in this direction, which is, ooh, that is clockwise. And then in the Southern Hemisphere, they tend to spin counterclockwise. And so that is because of the rotation of our planet. Isn't that interesting? So if we look at another source of oceanic circulation, we can talk about what is referred to as the ThermoHyline circulation. And hyaline refers to salt concentrations. So this is temperature and salinity driving currents. So you remembered our convection cell. So as water heats up, it tends to rise. And then as it gives off that heat and cools, it tends to sink. And so we can see that there are movements of water, ocean circulation. So here's an example of that. So we have these warm, shallow currents that actually come up this direction. And if you've ever been to the East Coast, you know that the ocean is much warmer there. And so this actually keeps the temperatures up here relatively mild as compared to, say, for example, on our other side over here of our continent, where temperature cold waters are actually coming down, right? So they are coming down. So the Pacific Ocean is colder than the Atlantic Ocean because of these ocean circulation patterns. So in some science fiction and also in some models of climate change, they predict that maybe this is going to slow this movement of this warm water. And so this is the idea that this is called a global conveyor belt of heat, and it's going up. And so this is going to cause like a mini ice age up there by New York, and England is going to start to get much colder because this conveyor belt of heat is going to stop. And that would be very bad. The other interesting thing about it is that we see that there are some places where cold water comes up to the surface. So where cold water comes up to the surface on the western side of our continents, we find that these tend to be very nutrient-rich waters, and these are called upwellings. So an upwelling is where cold water moves towards the surface. And so there's an upwelling off of our coast that brings nutrient-rich waters to the surface, and it helps to support the abundant ocean life that we have off the Pacific coast because of that cold upwelling of water.